Hello students, in our today's video we are going to discuss how to find the equation of the straight line in space. There are two different methods. Method number one is when a point and a parallel line are given. Method number two, when two different points are given, how to find the equation of the straight line. In each method we have two different forms. The first one is vector form and the second one is Cartesian form. Now let us take the model number one, equation of the line in space. Equation of a line in space. So we take model 1. A point is given. Say that point is A, that is x1, y1, z1, and a parallel vector B. These two things are given. So a point A and another one is a parallel vector B are given. Let us take the three-dimensional plane. Say this is x-axis, y-axis, z-axis, and this is the origin where the three axes meet. Let us take the point given, that is A, and here is a vector B parallel to the required line which is passing through the point A. So we are just drawing a parallel line here. To make it parallel, we take another point P, that is x comma y comma z, that is any point P on the same straight line which is required to us. And now we join this A with origin O. That means OA is nothing but A vector, that is a position vector, and join P with this origin. Say this is R vector, position vector of point P is R vector, position vector of point A is small a vector, and here this vector is parallel to the required straight line AP vector. Okay, now let us take the vector form, that is R vector is equal to A vector plus lambda B vector. Here this A vector is nothing but the position vector of the given point A, whereas B vector is the parallel vector and lambda is the constant, whereas small r vector, it is already known to us, that is a position vector of the point P. So by using this formula we can find the equation of the straight line passing through the point capital A and parallel to the vector B. So you can take any point, suppose say the point A is 2, 3, 4 and B vector, say this is 5i plus 6j minus 7k, whatever it may be. Now if you want to find the equation of the straight line passing through the point A, that is 2, 3, 4 and parallel to the vector B, that is 5i plus 6j minus 7k, write the formula first, that is R vector is equal to A vector plus lambda B vector. Don't confuse this A vector with the values of B vector. In the values of B vector we have AI plus Bj minus Ck, here plus Ck or minus Ck, whatever it may be. Now in place of A you write the first one, that is point A, that is 2i plus 3j plus 4k plus lambda B vector is, that is 5i plus 6j minus 7k over. So in this way we can find the equation of the straight line in vector form. The same if you want to find in the Cartesian form, slightly we make the changes. Already in our previous class we discussed about the direction ratios and direction cosines. Suppose here B vector is given, say B vector is equal to AI plus BJ plus CK. Don't confuse this B with the vector B vector. Here B is a direction ratio, whereas here B vector is the vector which is parallel to the required straight line. And now the point A, say the point is given as x1, y1, z1. Now the Cartesian equation of the straight line passing through the point A and parallel to the vector B can be written as x minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C. This is the Cartesian form. This form is called as Cartesian form. So here small a, small b, small c, these three are the direction ratios we are getting from the B vector. And here x1, y1, z1, these three we are getting from the point A given. Clear? Now we may have one doubt. Suppose we are given a straight line, we want to find the general point on the straight line. How we can find it? It is very simple. You take the value is equal to some lambda. Lambda is the proportionality constant. When we take this value is equal to lambda, we can get x minus x1 equal to a lambda. This can be written as x equal to, that means a into lambda, a lambda. So now we take this minus x1 to the right hand side, so automatically it will become plus x1. So we will get x value as x1 plus a lambda. Similarly, we can take this y minus y1 by b is equal to lambda. With that we can get y is equal to y1 plus b lambda, and z is equal to, take this value equal, so z1 plus c lambda. If you write these three in the open bracket, we will get x1 plus a lambda, comma y1 plus b lambda, comma z1 plus c lambda. This is the general point on the line. So now we learned how to find the equation of the straight line in vector form, equation of the straight line in Cartesian form, and finding the general point on the straight line. Now, okay, now we go to the next model. In this model, we discuss how to find equation of the straight line when 2 points are given. If suppose 2 points are given, say the point A is x1, y1, z1, and point B is x2, y2, z2. Now 2 points are given, we are taking 2 points in the space, x axis, here y axis, say this is z axis. Here we have taken the point A, say this is point B. When we join these two, we get the straight line which is required. We want to find the equation of the straight line AB. Now we will have the formula r vector is equal to a vector plus lambda into b minus a vector. Lambda into b minus a vector. You just to check this one. In the first one we had only lambda into b vector, whereas in the second model we have lambda into b minus a vector. So here we are taking this a with o, that is a vector, join this is b vector. Now we have r vector is equal to a vector plus lambda into b minus a vector. Clear? So if you substitute these values here in this, first we have to find b minus a, x2 minus x1, y2 minus y1, z2 minus z1. So after substituting all these values here, we can get the equation of the straight line passing through 2 different points. Clear? Now the same can be found in Cartesian form also. In Cartesian form, we have the formula x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Remember, this a, b, c are nothing but a is equal to x2 minus x1, b is y2 minus y1, c is equal to z2 minus z1. When you substitute the values here, we get the formula x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. This is the Cartesian form of the equation of the straight line passing through two different points. Clear? So, using these methods, we can find the equation of the straight line in vector form as well as in the Cartesian form. Suppose you may have the doubt, suppose we are not given the direction ratios, but we are given the direction cosines. No issue. In place of a, b, c, we can write LB, L, M, N. So, the formula can be written as x minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N. This will be in the model number 1, that is in Cartesian form. Okay. Remember, if two lines are parallel, then their direction ratios are same. Similarly, their direction cosines are also same. In the next video, we will discuss how to find the angle between the two straight lines. Thank you for watching.